Hi, Joel and Dave here to talk about section 5-2 of Absolute Java. The topic is reference in class parameters. The key concept is pass by reference versus pass by value. All objects are always passed by reference or passed by address, and this is a key point in terms of side effects. Another key concept is whether objects have the same address or different addresses. If we want to check two objects to see if they have the same address, we're going to use the double equal sign. If we want to check two objects to see if they have the same contents, in other words, they can live at different memory locations, but each have the same contents, we're going to use the dot equals method. And if we're a class developer, we are the ones that have to define what equals means. Okay, let's get started. Two different types of memory, right? Secondary memory, like a hard disk or USB, and main memory. Main memory is the expensive type of memory that you buy with your computer, and you probably got 4 gigabytes or 8 gigabytes on your laptop. And that's where the program is read into and run from main memory. Now, main memory consists of a long list of number locations called bytes. Each byte has 8 bits, and each bit can have the value 0 or 1. Now, each byte is going to be associated with an address. So let's consider the first byte of your 8 gigabytes of main memory to have the address 0, and it goes all the way up to 8 billion. Now, when we store data, it's typically going to take one or more bytes, and those bytes are going to be stored in a contiguous adjacent fashion. And the entire chunk of memory that holds the data will be called a memory location. And when we want to refer to the memory location, we'll refer to the first byte of the memory location. Now, in terms of primitive types, int takes 4 bytes, long takes 8 bytes, a float takes 4, a double takes 8. And you can think of the computer's main memory as being a long list of locations of different size data being held. So we're going to start at byte 0 all the way through byte for 8 gigabytes, 8 billion plus. And we talked about how the data can be of different sizes and stored at contiguous locations. So if I want to address the first 3 byte piece of data, it has address 0. The second 2 byte piece of data has address 3, and so forth. Now, when we declare a variable, that variable is associated with the location in computer memory. When the variable is a primitive type, like an int, a long, a double, the actual value of the variable is stored in the memory location. So if I have a variable d of type double, d is going to be associated with the memory location. And in that memory location, we're going to store the value 23. Now, each primitive type always requires the same amount of memory. So doubles are always going to require 8 bytes. Ints are always going to require 4 bytes. Now, unlike a primitive, when the variable is a class type, we're not going to store the value. We're going to store the address. And the object's going to be stored at a different location. Now, the address has a fixed size. Just like primitives, the value of a variable is a fixed size, and this one's going to be just 4 bytes. But unlike primitives, the value is going to be the address of the class variable or where the instance is located. Since we're storing addresses, 2 different variables can contain the same address or point to the same object. And the assignment operator can set the reference of one variable equal to that of another. So let's assume that we had 2 variables, and that variable 1 was holding the address of an instance object. If I say variable 2 equals the variable 1, both variable 1 and variable 2 are going to hold an address, the same address. So for grins, let's say that was a bank record. If variable 1 and variable 2 have the same address, that means they're pointing to the same bank record. So if I call the method withdraw on variable 2 for $200, I then call withdraw on variable 1 of $100, since I pointed to the same account, we just withdrew $300. Here's a pictorial, a couple pictures now to get us a better feel for the addresses and variables. I have a class, toy class, that has two data members. One name of type string, the other number of type int. If I'm in my program and I declare a variable, sample variable of type toy class, sample variable is going to be associated with a memory location. And in that variable, until I initialize it, there's nothing. There's no address associated yet. To associate address, I call the constructor. When I call the constructor new toy class, an instance gets created, and that instance address is put into the variable sample variable. That's what's happening here. When I call the constructor, it returns the address of where the instance lives, and it's that address that gets put into the variable sample variable. So variable 1 got an address back from the constructor, and it points to the actual instance location in memory. Here I'm declaring variable 2 of type toy class. I did not initialize it, so it has a null value. It does not have an address yet. But if I then say variable 2 equals the variable 1, the address of variable 1, which is 4068, will now get put into variable 2. So you can see that variable 1 and variable 2 hold the same addresses, which is to the identical instance. The impact of that is if variable 2 calls any method on the instance, it's going to be having a side effect, or it's going to be having an effect on variable 1, since both variables point to the same object. So class parameters. All parameters in Java, this is confusing, are called by value. Now a parameter is a local variable that is set equal to the value of its argument, right? So you got these method parameters, and when you call the method with arguments, those values for the arguments are put into the parameters. Any change to the value of the parameter cannot change the value of its argument. Now class type parameters appear to behave differently from primitive type parameters. They appear to be more like call by reference, because we're passing an address now. And by changing what's associated with the address, we're having side effects. Right? The value plugged into a class type parameter is a reference. Therefore, the parameter in the method becomes another name for the argument. And that parameter is going to have the same address as the argument. So any change made to the object named by the parameter will be made to the object named by the argument. Right? They're both pointing to the same instance. So let's get a look at something that does this to get more concrete about it. Here we have a class called toy class. It's in the package, edu Elon chapter 5, 2 private data members, a default constructor, a to-are constructor, an equals method, so you can check whether 2 different instances have the same content, a setter, and we're overriding a toString. Now I skipped over the one static method. This static method is going to take an instance of a toy class. And that instance that it takes, it's going to modify whatever the instance's name is to hotshot, and whatever the instance's number is to 42. So here's our main method in class parameter demo. Creates an instance of an object with the name Mr. Cellophane, a value of 0. It prints it out so we can see Mr. Cellophane 0. We then call the static method changer, and we're handing it an object. So the address is getting passed. And remember, when you pass the address, it took that object and it put in the name hotshot and the value 42. So now when we print out the original object, we can see the impact of the side effect, and we get hotshot 42. Pictorially, we had an object that was set equal to new toy class with the name of Mr. Cellophane and a number of 0. But when we passed it as the argument to the static method changer, the address was passed at 3078. And the actual parameter, the formal parameter of the changer static method was a parameter, so it got the value 3078. When a parameter had the value 3078, when it changes the name to hotshot and the number to 42, it's doing it to the same object referenced by the original AND object. So, big differences. A method cannot change the value of a variable of a primitive type. Right? So we'll have no side effects when we pass a parameter of a primitive type. But when we pass instance variables of a class type, we then can have side effects. This example, toy class 2, was trying to show that you can have side effects when you pass a class reference, but not a primitive. So there were two methods created. One was called make equal, so that when it got passed a reference or an address, it would change the address that it was passed instance name to the object that it was in, and it would change the number of the one that it was passed to the number of the object that it was in. So in this application main method, we created two different variables. One, object 1 of type toy class that had its own address to a toy class. We created object 2, an instance of a toy class with a different address in its own instance. We set object 1 equal to the name Scorpius and a number of 1. And we set that separate object 2 to its name John Crichton and a number 2. That's fine. So each is independent instances. We then told object 1, the calling object, we called its make equal method. And we passed it object 2. And remember, object 2, when it got passed, it turned around and wanted to set its name and its number to the calling object. So object 2 is going to have its name changed to Scorpius and its number changed to 1. And when we print that out, we see that that was in fact the case. So when we pass references, we can have side effects. This other method, we were passing it the integer 42. And since 42 is getting passed by value, any change to the parameter inside of try to make equal is going to have no impact on a number. And that's what's shown by this output. Right? Object 2 was impacted since it passed an address. Its name now became Scorpius in 1, but passing by value of a primitive type had no impact. Okay, pitfall of using equal and double equal with class variables. When you use equal with class variables, you're going to set them both equal to the same address. When they're both equal to the same address, if one changes the instance at the address, the other will feel the impact. Double equal sign. When you use a double equal sign with class instance variables, it's only checking to see if these instance variables have the same address. It's not checking to see if these different instances have the same contents. If you want to check for contents, you have to write your own equals method as the class designer, and you determine what equals is. Now, when we create a variable of a class, if you don't give it a value, it's going to have the value null. Null means no address, no real value. If it has null, you can't call any method on that instance. The only thing you can really do when an object has the value null is to test to see if it's null. You can do that with the double equals or the not equals to check the address. And you should always check the address before you try to call a method. If you don't check for null, and it is the value null, when you try to call a method, you're going to get the infamous null pointer exception. That concludes the lecture. Hope you enjoyed it.